This is a video about isotopes. Isotopes are atoms of the same element with different number of neutrons. So let's really quickly just review some parts of the atom right now. So these are just some reminders. Hopefully you know all of these things. So if this is my atom right now, so these are called energy levels around my atom. Inside the nucleus, I have positive particles called protons. Those are in my nucleus. So we'll put a couple of those in there. And then I also have in my nucleus some neutral neutrons. So we'll shove those in there as well. Surrounding my nucleus are, like we said earlier, my energy levels, and there are electrons on the hair. So this is just kind of a quick sketch reminder of what particles are where. Also, some things to remember are, we call these the subatomic particles, sub within the atom, right? The particles that are within the atom. And these are our notations, our abbreviations we use. So the E with a negative because electrons are negative, the P with a positive because protons are positive, and neutrons have no charge. So technically our nucleus has a positive charge because our neutrons have no charge, and the outer charge of the atom is negative. Okay. Moving on, so back to our definition about isotopes. So we know that there are tons of elements on the periodic table, right? Here are tons of elements. And so what we were learning here today is that elements such as hydrogen, lithium, sodium are going to have multiple versions of themselves. So let's take a look at what that looks like. Let's go ahead and look at hydrogen as an example. So here is an atom of hydrogen. Here's another atom of hydrogen, and yet another atom of hydrogen. So first of all, how do I know that these are atoms of hydrogen? Remember, your atomic number identifies the element, and that atomic number is your proton number. So let's take a look at hydrogen on the periodic table to see what its atomic number is. And so again, you want to bring out your periodic table, right, and find hydrogen, okay, and look and see, right? So here's basically the way hydrogen would look on the periodic table, right, in a box with a symbol and a mass, atomic mass on the bottom. This is not my mass number. We'll get to that in our next video. So let's concentrate on that number there on the top. That's the atomic number. That's your number of protons. So hydrogen has one proton in its nucleus. I find that out again from the periodic table. So let's go ahead and see, are these actual atoms of hydrogen? And I see one positive proton, one positive proton, one positive proton. So let's zoom in a little bit there. Okay, so I've identified that all of these are hydrogen. So let's go ahead and write that down. We've got hydrogen, we have hydrogen, and we've got hydrogen. Okay. So how is it possible that these are all hydrogen, but they look a little different? Well, these are called isotopes of hydrogen. So they're atoms of the same element, atom of hydrogen, atom of hydrogen, atom of hydrogen. So atoms of the same element that have different number of neutrons in their nucleus. So notice in this first example, this one has one neutron, this one has no neutrons, and this one has two neutrons. So I notice that then this is basically the definition of an isotope. So atoms of the same element, they have different number of neutrons. Now, if you notice, I still have that electron particle on the outside. That doesn't matter. So technically, my electrons and my protons don't really matter in the definition of an isotope. It's my neutrons I'm looking at. So now I'm going to show you a notation of how to write these isotopes. So because by looking at this, it looks like this is the same as this is the same as this. And so what we like to do in order to distinguish these isotopes is that when we write the element name, so remember that's a name, or we can actually use a symbol which would have been H. We use a dash, and then we put the mass number after it. So remember, our mass number is our proton particles plus our neutron particles. Remember, electrons don't really have a mass that is actually used because their mass is so tiny, it's basically negligible. So with that being said then, my number of proton particles are 1 and my neutrons are 1. So 1 and 1 make 2. So this is isotope hydrogen-2. This one over here is hydrogen, and I have no neutrons, so my neutrons are 0, and the number of proton particles I have is 1, so my mass is 1 plus 0, which is obviously just 1, so this is hydrogen-1. And then this last one here, same thing, I count up my particles, I have 1 proton and 2 neutrons, so that makes hydrogen-3. So this is a way to annotate, to notate isotopes with their names. Hydrogen-1, hydrogen-2, hydrogen-3. Again, that's a mass number. So it might help to put that in your notes, that that's a mass number, right? That's a mass number. Mass number. So if I was to ask you which isotope is the heaviest, you'd obviously say this one because it has the most particles in its nucleus. Which one's the lightest? That one. Okay, so now let's take a look at some other atoms of hydrogen and see if you can tell me if these are different isotopes or the same. So we've got this one here. Is this a different isotope? Have I found a fourth isotope of hydrogen? And the answer is no, I haven't. Right? That is not a different isotope. That is the same as this isotope. Is it still hydrogen? Yes, but it's not a fourth isotope. It is just another one of these isotopes. So this atom mimics this atom, and that's definitely possible. So let's look at this one. Is this a fourth isotope? And the answer is again, no, right? That is just the same atom as this one. So I didn't find a fourth isotope of hydrogen. Rather, I've just found another atom of hydrogen. So these are still atoms of hydrogen. This is still an atom of hydrogen. And again, the reason why I know that is because of the 1 proton, right? So if I want to wipe these out and now ask you questions about these, right? Are these isotopes of each other? And the answer is yes. Atoms of the same element, hydrogen, they have different number of protons. They have different number of neutrons. 1 neutron, no neutrons. So these are isotopes of each other. Okay, moving on. Now let's take a look at carbon and look at carbon and its isotopes. So we've got here this atom, and this atom. Are these the same atom of carbon or are they isotopes of carbon? So I look here and I say, how do I know this is carbon? Well, remember in our last example, our pink particles were representing protons. So we'll keep the color the same. So I've got a pink here. So 1, 2, 3, 4, 5, 6. So I have 6 protons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I look on my periodic table and I look and find carbon. So let's get our periodic table. And here is my carbon. And if I zoom in on your periodic table, it would look like this, a box with a C in the middle and the 6 at the top. So this atomic number is equal to my number of protons. So that's how I know that these are all carbon. So I can at least start by writing down the name. Carbon, carbon. And then remember, if these are isotopes, then I can actually let you know what the isotopes are. Remember, isotopes are atoms of the same element, so far same, that have different number of neutrons. So the blue ones are the neutrons, so let me count them. 1, 2, 3, 4, 5, 6. So there's 6 neutrons here. 1, 2, 3, 4, 5, 6, 7. Oh, 7 neutrons here. So definitely these are isotopes of each other. And then 1, 2, 3, 4, 5, 6, 7, 8 neutrons. So these are all isotopes of each other because I have different numbers of neutrons, but I have the same number of protons. Remember, the protons were 6 protons. 6 protons. So this is just some work I'm putting here. Okay, but really let's focus on the name. So what is the name? It's carbon dash, remember the mass, and the mass is adding up my two heaviest particles. So I've got 12 total particles there. I have 13 there, and I have 14 here. So carbon dash 12, carbon 13, carbon 14. These are all isotopes of carbon. And so I then say, well, is this a fourth isotope, right? And we say, no, this is the same isotope as this. So right now, these are carbon's most stable isotopes. So sometimes elements have more than just a few isotopes, but some of their isotopes are not very stable. And so it's kind of coincidental that carbon has 3 stable isotopes and so does hydrogen. That's not always the case. You can have more or less isotopes that are stable than 3. This example just happens to have it. So what are these rings and these black dots? Those are just energy levels with electrons, but electrons don't really matter when you're trying to figure out an isotope, okay? All right, moving on. Now let's take a look at some of my isotope charts that I'm going to be seeing. So here's an isotope chart, and if you notice here, we just learned about this notation, right? Carbon dash 12. Let me zoom in. So we learned about this notation, carbon dash 12. Remember, 12 means mass number. And if you notice in this isotope chart, I have some missing boxes, but I have some information. So I kind of have to use it like Sudoku, that game where you get some pieces of information and then you figure out the rest. So I know from the periodic table, I can always figure out my atomic number is equal to my proton number. So immediately, if I know this is carbon, I know the atomic number is 6 because I looked it up on the periodic table. And I know that that always equals my proton number, so I can fill those in. Next, if this is neutral, get a more prominent marker. If this is neutral, then I know my electrons are equal to my proton. And nothing gives away that it's not neutral. So then my positives will equal my negatives. Now I know my mass number are my protons plus my neutrons, but if I notice here, I don't have anything about neutrons. So how do I figure out my mass number? Well, remember, that's what we said this is. That's your mass number. So I'm going to put that there. So now I have all of that, and now I'm going to move on to my isotope notation, or my isotope format, or we can call it a nuclear notation or a nuclear symbol. Those are all different synonyms used. So nuclear symbol, isotope notation. I put the element in the middle, so that's carbon, and it spells, so here's the element in the middle, and it spells Ma going down, your Ma, not your Pa. That's mass, so here's my mass number, 12. And your atomic number, 6. So that's my notation. Okay, moving on to the second one. I noticed that my mass number is 14. Okay, that doesn't help me, but my protons is 6. Remember, it's always your atomic number and your protons that help you identify an element. My protons are equal to my atomic number. So I go on the periodic table and find element number 6. Oh, that's carbon. So it's still the same one we're dealing with. So I write that here, carbon. And I want to know, is this going to be the same atom as the one up here, or is this going to be an isotope of carbon? And so I look here and I say, well, my mass is 14. So therefore, I must have a heavier version of carbon. What would cause carbon to be heavier? More protons? No, my protons are the same. If I change my protons, then I change my element. So it's not my protons that make it heavier. Is it my electrons? No, electrons' mass is basically negligible. It's not very heavy, so it doesn't really register in. So it's the fact that I have more neutrons in this example. Even though I'm not being asked about neutrons, I should know why this mass is heavier than this. Okay, so then back to electrons. I can assume because no directions or anything was given about this not being neutral, so I can assume it's neutral unless my directions say otherwise. And then I'm going to write my notation that carbon in the middle, the mass is 14, the atomic number always stays the same. Ma going down. It's important to write that. So these are isotopes of each other. These are isotopes of carbon. These are not the same atom. These are elements that are the same and have different types of atoms right? And so they're atoms of the same element, and they have different number of neutrons, heavier, lighter. Okay, now, one of the biggest mistakes students make is not understanding the difference between isotopes and ions. So let's take a look at this. Might be good to pause the video, write this down, and then listen to me explain it. So ions are charged particles. In other words, the only way an atom can be charged is if its number of protons, so here's a proton, does not equal its number of electrons. So in this instance, they don't equal each other. I have an extra positive, which means I lost an electron. So this is charged, a leftover charge of +1. In this instance, this is not charged, this is neutral. So charged, I can lose electrons, and I have leftover +2. I can never lose protons. So I can either lose or gain electrons, okay? So that's what an ion is. That's not what we're talking about in this video. In this video, we're talking about isotopes. But the thing is that isotopes are atoms, right? So they're atoms of the same element. And so your isotope can gain or lose electrons. It doesn't really have anything to do with the fact of what isotopes are. It's just another thing happening in that element, right? In that atom. So you can see here in this instance, this magnesium is not charged. There's no ion notation over here, whereas this one is charged. So what does this 2+ mean? This 2+ means that I lost 2 electrons, right? I lost 2 electrons. Here, let's bring that back. Here we go. How do I get a 2 positive? I lose 2 electrons, and now I'm left with 2 positive. So I lost 2 electrons, right? Is this an isotope? Sure, right? I'm in isotope notation. I have my mass number, my atomic number on the bottom. Let's look at this one, right? So these are the same element, but it's an isotope of magnesium, I know. I could see my notation here. Remember, all our elements have isotopes. This one is an isotope that does not have a charge. So I didn't gain or lose any. So I basically had the same number of electrons as protons, right? And this is just an example. Magnesium obviously has 12 protons, so it'll have 12 electrons if it's neutral, right? In this instance. But in this instance, I lost 2 of those electrons. So instead of having 12 electrons, I have 10 electrons. Okay, and again over here, this is just a basic ion. Notice I don't even have to put any isotope notation if I'm just asking about an ion. Okay, so now let's look at another chart and do a little bit more practice. In this instance, I have sodium-23, sodium-24. I know these are isotopes of sodium. They have different masses. This is the heavier one, so there's more neutrons here. Looks like 1 more neutron. So that's good to know, even though the chart didn't ask about it. Sometimes your chart will ask about your neutrons, sometimes it doesn't. So in this instance, I give you your electrons, and if you notice, my protons are not filled in. So how do I figure out my protons? Remember, go to your periodic table and find sodium. So here's sodium on my periodic table. Your atomic number on the top there is equal to your number of protons. So you have to get that from your periodic table if it's not given to you. So 11. How about this one? Remember, your protons don't change. If you change your protons, then you change your atomic number, then you change your element. So that's not possible. You can't gain or lose any protons. If you do, you just become a totally different element. And this is sodium, so it's still 11. Okay, good to write that down. Now, I can clearly see that this is sodium that's neutral because my positive particles equal my negative particles. So I won't have a charge, neutral. Whereas this one looks like I lost 1 electron, which means I have an extra proton. Extra proton, so a positive charge to indicate that charge. And this asks me for my nuclear symbol. Remember, my nuclear symbol spells the word Ma going down. Where do I get the mass? Right here, 23. Where do I get the atomic number? My protons. No charge because they're equal. Where do I get the mass? 24, heavier isotope, more neutrons in there. And where do I get my atomic number? The same. So my atomic numbers obviously should be the same because this is sodium. This means different number of protons and electrons. That's the end of the video.